Okay, guys, so today on our lesson for class, we're going to keep moving along with mole conversion. So last class, you did mole conversions with Avogadro's number. So you guys either went from mole to any type of particle. So particles are atoms, molecules, ions, formula units. You either went from a mole to a particle or you went from a particle to a mole. So in this case, and you just did the warm up on it, you either were using Avogadro's number with multiplication or division, and you guys would set up factor label and you would make sure that your units would cross off and you would have circled your unit that you wanted to end with, and it matched what the problem asked for you to do. So I was either asking you to have particles right here or moles right here. So today we're going to continue with that with something we just started this unit with. So we started this unit with molar mass. We started this chapter with this because we will use it and be able to do conversions with molar mass. So molar mass is really just the sum of all the masses of the compound or the molecule. So the first video I ever made for you guys was finding the molar mass of ionic and covalent. You do them the same way. You just really add up all the elements in a compound or molecule by using the periodic table. You look for the elements that are on or in the compound, and you find each and every one of them on the periodic table, and then you add them all together. So we're going to use that in conversions because molar mass has a unit. And every time I would make you guys do a worksheet or anything, I said, remember to put the units, and you guys would key in on the Google form that the unit for molar mass is grams per mole. So what grams per mole really means is that it's however many grams per 1 mole. This is similar to things like you use often when you're driving a car. The speed limit is a certain amount of speed, miles per hour. So it's miles per 1 hour. So every time you've been writing grams per mole, that really means that many grams and whatever it corresponds to in that compound or molecule per 1 mole. And this will help us out because we can do conversions just like we did the past class. So the past class, I had 1 mole is equal to 6.02 times 10 to the 23rd particles. This, we're going to have however many grams equals 1 mole. So then we can easily do the conversion if the question is asking us to go from grams to moles, which is helpful when figuring out how many moles you need of a substance. You then have to measure out how many grams in real life. So you will have to mass it, but you have to figure out that mass before you start a chemical reaction or a lab. So something that we would have done in class is actually do the measuring out of these things, and it would have kind of came to full circle of why we need to do these things. But we're going to just keep trying to go along with the material. The next video will show you really how to do these conversions, and you're going to need your periodic table today. And if you are writing notes, I would continue to take another sheet of paper and continue with these notes. There are 2 notes in the example, or 2 examples in the notes that we're going to go over right now. Then we'll do some practice. And then I'm going to also put on the screen kind of an easier way to do these problems. thing I started to mention in the last video, and I don't know if I got cut off with the 5-minute limit, but these problems are going to appear mixed. So it's not always going to be, oh, this will be a mass example. This is a particle example. They're going to all end up being mixed, and you will have to figure out what steps you need to do to complete the problem. So I'm going to try to help you and get you ready for them separately, and then we'll do some practice where they are mixed. But for now, we're just going to focus on mass examples today. So these will be any examples using molar mass. So the first step you will want to do is find the molar mass. And then you will want to write it as blank grams equals 1 mole. That will help you figure out, because the molar mass is going to be grams per mole. That is the unit for molar mass. So you're going to want to write it out as blank grams equals 1 mole. So you can easily set up your factor label with whatever you're trying to figure out. So like, for example, the first question is asking, and this is straight from the notes, so if you're using your note packet, just keep rolling along. If not, you can write down this problem. What is the mass of 2.56 mole of zinc chloride? So we're given we're given moles in this case, and we're trying to find mass. And we have to figure out a way to relate moles to mass, and in that case, it would be molar mass. If it had particles in here, you would use what we did last class. But in this case, we are given the compound zinc chloride. And this, I'm going to try to make it easier from the time being. This one, you actually will have to figure out the formula. I'm going to try to keep giving you the formula. But if you remember from the past unit when we did ionic and covalent naming and writing formulas, this is an ionic compound, so you would have to use your ions. Zinc is a +2. Chlorate is ClO3 -1. So those charges don't equal 0. Your compound or your finished product would look like this after the crossover method. So after you figure out the formula, like I said, I'm going to try to give you those formulas so you don't have to do that step. You will figure out the molar mass. So in this formula, we have 1 zinc, and we did this at the beginning of the chapter. If you distribute that 2, we will have 2 chlorines. And if you distribute that 2 to the 3 oxygens, we will have 6 oxygens. So now in these parentheses, you will go to your periodic table. Your periodic table, you look for zinc, chlorine, and oxygen, and you put their masses in the appropriate parentheses. So 65.39. Chlorine is 35.45. And then oxygen is 16. So then your first step is to figure out the total molar mass. So if you put in your calculator, 65.39 times 1 is just 65.39. 2 times 34.45 or 35.45 is 70.90. And then 6 times 16 is 96.00. In the last video, it cut short, but 96 is the total mass of oxygen. So when you add 65.39, 70.90, and 96 up, you get 232.29 grams per mole. So we need to use this for our conversion. So what that number really means, and I'm going to erase some of this because you probably have more space, but I only have the screen space. So I'm going to try to just erase all my writing. The molar mass will be used to convert the moles to the mass in the problem. So I just rewrote the formula and the molar mass closer to the left so I can show my work. But like I said, I want you guys to write out the molar mass as the mass that you got is equal to 1 mole. And this will help us do our problem. So in our problem, we're going to start with moles and we're going to want to get to mass. So you always start with what you underline. And in this case, that is 2.56 moles of zinc chloride. You always start with that over 1. You then want to cancel out whatever is on the top with whatever. So we're trying to cancel out moles. So we will then place the moles on the bottom to cancel them out. So in our conversion, there is 1 mole for every 232.29 grams. So we will continue by writing 1 mole down here. Is equal to 232.29 grams. I'm sorry, I'm running out of space, but you are just rewriting. That looks like a 1. I'm just making it worse. I'm sorry, guys. 232.29 grams, this number at the top. So if you use a different color, if you want to make sure that you are canceling out your moles, you will be done with grams. So in your calculator, you will do 2.56 times 232.29, and you will get 594.66 grams of zinc chloride, which you can write out the name or you can write out the formula. And we already went over the formula, so you can just write what it's given. That would be your final answer. You can check your work by just making sure that you crossed off all the units and they are good with your conversion factors that you started with. So you would never have, it will always be 1 mole of that. It's not going to be 232.29 grams equals 5 moles. It'll always be this 1 because you're doing a molar mass, which is grams per 1 mole. So we just did an example going from moles to mass. We can also do an example going from mass to moles. So it's just the flip-flop. You're just figuring out the same, really, you're using the same steps to figure out a similar problem, but you are doing the opposite. It will look very similar, but you have to kind of switch up your conversion factors. I just moved around the next example, but it states how many moles are there in 94.40 grams of sodium sulfite. So the first step is really figuring out what you're given and what you need to find. So we're starting with grams and we need to go to moles. When you see that you are going from a mass to moles or moles to mass, you know you will need to use molar mass. In this example, again, you will have to figure out the formula. Na is a +1. Sulfite is SO3 minus 2. So you would have to do the crossover, giving you a formula of Na2SO3. So we're figuring out the molar mass of Na2SO3. You can get out your periodic table and find the total mass or the total sum of each one of these elements. So there are 2 sodiums, there's 1 sulfur, and there's 3 oxygens. Sodium has a mass of 22.99. Sulfur has a mass of 32.07. And oxygen has a mass of 16. So if we get our calculator out, 22.99 times 2 is 45.98. Sulfur's mass, 32.07 times 1 is simply just 32.07. And then 3 times 16 is 48. So to get the total molar mass, we can do 45.98 plus 32.07 plus 48. And that will give us 126.05 grams per mole. If you want to write it out, like I said, that really means that it's 126.05 grams is equal to 1 mole. So we can use this now in our conversion factors. I'm just going to kind of clean this up a little bit so we have more space to do the conversion. So we are starting with 94.40 grams of sodium sulfite. Starting with grams, we will want to cancel out grams. Grams will have to be on the bottom, which in this case, we just figured out the molar mass as 126.05 grams. We are trying to get to moles. That is what's circled in the problem. So we will put 1 mole at the top. So now we will multiply across and divide down just like we have been doing for the past conversion problem. So 94.40 times 1 is simply 94.4 because it's multiplying it by 1. And then we're going to divide 126.05. Our answer is 0.75 grams of sodium. Not grams. Sorry. The question is asking for moles. If we would look at our units, the grams cross off and we're left with moles. So our answer will be 0.75 moles of sodium sulfite. And that matches what we're looking for in the problem. And we just did another type of conversion problem. So we just finished our last example for today's class, but I did want to throw something on the screen that might be helpful for someone that wants more structure with their notes. So if you want to write down this kind of, not flow chart, but it really is just to help you figure out what you need to use when you're given a problem. So this is really a chart that says mass, moles, and particles. So in these problems, it's going to ask you to go from mass to moles sometimes, or sometimes it would ask you to go from moles to mass. This chart really tells you how to get from moles to mass. So like the problems we just did, when you're given a question that's asking you to go from moles to mass, you have to multiply the molar mass. And that's how you get from moles to mass. Another example would be going from mass to moles. You have to get from mass to moles by dividing the molar mass. And this also holds true and extends to what we did last class. So in the last class, I gave you examples where you had particles, and I was asking you to get to moles. When you do that, you have to divide by Avogadro's number. And you guys did that in the warm-up today, and we'll continue to do that. And we're going to also tie in to problems where you can go from mass all the way to particles. So this is helpful in that scenario also. So particles, if you want to get to moles, if I give you atoms or something like of that nature, you will divide by Avogadro's number. If I give you a problem where we start in moles and I'm asking you to find atoms, you will simply multiply by Avogadro's number. So this can be helpful if you want to jot it down and you're looking through the examples that are mixed. You can really figure out what you need to do just by looking at this graphic. So I'm just going to put that up there for you guys to write down. Let me know if you have any questions. I'm going to give you a practice worksheet after this. So I'll be on chat all day, or you can email me with any questions. But let me know. The next class we'll just do more mixed review, and we'll start doing multiple step problems. So going from mass to particles or particles to mass. So that'll involve 2 steps of a conversion. But if you're using this graphic or you know how to get from one thing to the next, you should be fine with this topic.